All right, just one more day after today. We can do this. All right, so these are all different ways of stating the tolerance. And so you have to be able to read 4 pieces out of it. Unfortunately, this one only has 3, but you should be getting 4 things out of it, which is the nominal. That's always the number that's up front. Make sure you put units everywhere. It takes half a second. Okay. Max, you just add them. So that's 0.0186 of a meter, right? We add these two together where it says plus, and we get that. Make sure you have the right amount of decimals. We subtract, you get 0.0177 of a meter. That's your min there. So we just subtracted that. Because you get to keep this, so if I asked you for tolerance, you would just go, right, max minus the min, right? You subtract these two to get your tolerance. That's the safest way to do it. And we are at 0.0009 of a meter. That would be your tolerance. Okay. Don't forget how to find the tolerance. When it comes to definition, I would like you to say something like tolerance is the range of acceptable values, or right, it cannot be greater than a certain value or less than a certain value for it to be acceptable. There are limits on the low and on the high end, something like that when you want to define it. Next, the nominal here, we just copy that. Inches, or the two marks if you want, it's up to you. If you add them up, you get 0.048 of an inch, so I'm using the marks there, and 0.041 of an inch when you subtract to get the min. The tolerance, you just want to write it down for yourselves. 0.007 of an inch would be the tolerance there if I had asked you for it. And here comes the harder piece of the whole operation. You're given some sort of tolerance, one of the formats, and they're asking you to rewrite it in the other formats. And there are 4. You go back to page 92, somewhere in there, 93, there are the 4 there. I would say this. Do this for yourselves. Nominal. No, sorry, I thought I did, with you I did min, max. I'll stick with it. Min, max, tolerance, and nominal. I think that's how I did it. So you should be able to, whichever one you're given, you should be able to extract these 4 from it. Nominal is the first one I'm going to write down because that's always the front number, 67.50 millimeters, right? I'm bringing it down on the side here. And then I'm going to go with the min, which is this minus that. That's exactly 67 millimeters. I tend to keep the decimals. I'm almost assuming that this device that I'm using is going to show me those 2 decimals across the board, right? But it's not. I'm not going to mark it wrong in this case if you just go 67. And then at 67.5 plus that's 68 millimeters. Tolerance is subtracting these 2. You can probably do this in your head, right? That's 1 millimeter is the tolerance there. And then, now that you have this on the side, you come over here and you just take the values out of it. This format asks for max and min. So just write 68.00 millimeters, 67 millimeters. Done. You got 1 mark for that. This one is asking for the max units, right? Plus 0 minus the tolerance. The tolerance is right here, 1.00 millimeters. This one is asking for the min, 67.00 millimeters. I go minus 0, and then it's plus the tolerance, which is 1.00 millimeters. Okay, so once you have your inventory, which you can do for any one of these, I can give you any one of those, you should be able to get it in this format, and then take it and rewrite it however you, whatever you need to do, right? You just take it from this inventory here, and you got it, right? The only exception, yeah, a bit of a ambiguous is if I were to give you this, the nominal is not stated. I'm not going to ask you on a test what the nominal is in this case, but we assume it's halfway. If it's ever on an assignment or whatever down the road, we assume it's halfway. But it's not always the case, but we will just make that assumption. Okay, all right. You can put this somewhere in, under your notes or whatever. I will now give you an AC. This is going to take a little bit of a break from tolerance. Go back to precision uncertainty. And while you do that, I will do the attendance and try to think of a checklist that can help you. I want you to review it. So back to precision. It's more precision and uncertainty based. All right. Some of these questions you probably recognize, but state the precision and uncertainty of each instrument. So there's a number. So this is precise to the nearest 0.1 of a centimeter. Take half of that. You get that. The length in this case, you're down to the nearest hundredth, right, of a centimeter. That's the precision of this measuring device. And so half of that is 0.005. Use your calculator if you're not sure. The weight, that's how precise that is. And so uncertainty would be half of that. And some pictures in here. Yeah, some of you are wondering, what are the units? It's PSI. Your tires, right, are measured in PSI. Pounds per square inch. It's a longer way to explain, but it really just measures how much pressure is in something. So if you have I'm thinking tires is the main one. If you have a compressor at home, right, you might have one in the garage, right? The motor always kicks in when it's too low to fill up the tank, and then it goes back down. So in any case, you look at the markings, right? So 1, 2, 3, 4, 5. There are five spaces between 10 and 20, so I'm thinking it's 2 psi is my precision in this case, and 1 psi is the uncertainty therefore. Right? So just count, kind of think, how much do I go up by to get to the next number, right? So sometimes you have to kind of just figure it out. You can go 10 divided by 5. That would give you 2 psi as well. Okay, here, my precision here is 10, right? 10 milliliters. And my uncertainty, therefore, is half of that. It's always half for the uncertainty, okay? All right, so that's how you work with pictures. And the following measurements, I asked you to state them with their uncertainty. You've done something like this. So really in the background, you figure out the uncertainty of each measurement, right? And then you state it like this, 23.5 inches plus or minus 0.05 of an inch. So the measurement with its uncertainty, because we're going to need it later, right? That skill is important when we're going to combine. So precision here is 1/4 of a foot. So my uncertainty would be 1/8 of a foot. So this would be 14 1/4 of a foot plus or minus 1/8 of a foot. And yes, if you did that as a decimal, that's fine. This would be 0.125 or something. Yeah, I think so. So precision here is 0.001 of a millimeter. Don't ignore that 0 at the end of that measurement. It's very specific. It's telling us that that's how precise that device is. Right? And then, so now you state your measurement with its uncertainty. Okay. And then here, this one would be precise to the nearest 0.1 of a second. And uncertainty is 0.05 of a second. So you would go 4 minutes, 23.5 seconds, plus or minus 0.05 of a second. And you could always get your min and max out of that. Precision here is 0.01 meter. Uncertainty is 0.005 of a meter. So this would be 350.00 meters plus or minus 0.005 of a meter. The more precise you are, the smaller your uncertainty, right? The more decimal places you have, the smaller that uncertainty will be. It's almost negligible at this point, right? It's not even worth mentioning. You try to start at a construction site, and I dare you to say it that way, they'll probably make fun of you, so don't do it. Because it's so small, right? All right, next page. 3. Which beaker is more precise? Explain, show work to earn marks. So it's very important to show your work, and this is how you do it. This is one way to do it, right? It's a bit small, I get it, but you can tell that you're going up by 100, right? So you're not looking at how many marks there are, you're looking for exactly what each mark represents. This one has, oh boy, that's small. Can you tell it's 20 though? I hope so. I need to make that bigger. And precision, this one here goes up by 50. Okay. So you have to say that this one is more precise. Okay. More precise or most precise probably. Comma, due to smaller or smallest increment. Right? You say that it's actually going up by 20 milliliters. Doesn't matter what the size is of the thing, it's the increments that it goes up by. You're able to be more precise. You don't have to guess, right? Or guess less. A welder is welding 3 pieces together to strengthen the bottom of a trailer. He buys all 3 pieces online and knows that they measure as follows, right? Determine the precision and uncertainty for each piece. So I'm going to go 3.2, right? Should I do it side? I'll do it like this. This is 0.1 foot, so uncertainty is 0.05 of a foot. 2.75 feet. I'm going to try to go a bit faster because you're done already. So you'll just catch my mistakes, right? And then 4 feet has a precision of 1 foot, has an uncertainty of 0.5 of a foot. How's that? So 1 mark for each you would have received there. Calculate the combined length of the pieces, including its uncertainty. So we go 3.2, 2.75, and 4, but each and every one of them has an uncertainty. So we're going to copy that 0.05, 0.005, and 0.5. Right? So regardless of what happens here, you may have to subtract depending on what the question is saying. Am I cutting? Am I adding? Am I welding things together? Right? So here you would get 9.95 plus or minus 555, right? 0.555 of a foot. So it just happens the way the decimals are lined up that it is like this, right? So that would give you 2 marks there. Combined maximum and minimum, the largest or the smallest. So don't always think of their max and min, but what's the, and sometimes it's only one of them that you ask for, right? What's the maximum that could be the greatest length of these pieces welded together? So the max is 9.95 plus 0.555, and the min is 9.95 minus 0. I'm going to need my calculator for that one because I just want to make sure I get this right, and I am in feet. So that's the longest those 3 pieces could be. And then I'm going to go and subtract, and that's 9.395. Do not round in this unit, right? So there are your 2 values there, the greatest and the smallest length possible. There's a trim piece of 2.4 meters. You're cutting off 0.5 for it to fit. Calculate the total length of the trim after being cut, including its uncertainty. So this is a subtracting question. It's 0.1, the precision, so 0.05 is the uncertainty, and they're both having the same. So it's okay to, I would show more work if I were you, just in case you get it wrong. So you have to cut meaning that's subtracting, so it's 1.9 meters plus or minus, you add this up. You always add the uncertainties like that, okay? It's only asking for the uncertainty and the yeah. So that's it, that's all we do there. If you measure 50 pieces of wood as this, what would be the combined uncertainty? And that's just the idea that you take 50 pieces, right, and just multiply it by 0.01 of a centimeter, right? So that should be 0.50 centimeters. So the combined uncertainty, if they just asked for like the combined length, putting 50 pieces together, you would have also had to, right, multiply this by 50 as well. But this is just the uncertainty that they were asking for. So that's the idea there. Or you can add it up 50 times. It's up to you, whichever you find easier. All right.